video, what's going on, Algebra Bros? In this video, we're gonna be doing two more log function graphs. So let's go ahead and dive right into it. We'll be starting with example 5, where we have log base 1/2 of negative x plus 3. So let's take a look at that base. In the words of Meghan Trainor, it really is all about that base. Our base a is 1/2, which is less than 1. So prior to any transformations, let's look at what points would be on the graph of just log base 1/2 of x. And those 2 points would be 1, 0 and 1/2, 1. So I'm going to go ahead and plot those. And as we noted in a different video, this will be a graph that decreases from left to right. The left end going up towards the positive part of the x-axis, and the right end slowly creeping its way down to negative infinity. Now, let's take a peek at what's on the inside of the argument. In particular, we have a minus sign in front of x. Now, since this is within the argument in front of x, this is going to generate a y-axis reflection. So what I'm going to do is I'm going to take those 2 points that I originally plotted, and I'm going to reflect them across the y-axis. So we'll have negative 1, 0 and negative 1/2, 1. And this would be the y-axis reflected version of the graph. And I'm dashing this one in as well because there's one more transformation. And as you might tell in advance, it has to do with this plus 3. Like it did for us before with previous transformation work, since this is at the tail end, it's a vertical shift, and we can think normal with this. It's going to move our graph up by 3 units. So let's take those 2 points from the reflected graph and move them up by 3 units like a g-unit. Now, this entire time, the vertical asymptote is undergoing these transformations as well, but as you might be able to tell, there's not going to be a new location for it because with a y-axis reflection, the vertical asymptote is on the line of reflection, so that doesn't reflect anywhere. And if we move it up by 3 units, it's still going to be a line going along the y-axis. So to finish things up, I'm just going to connect these points much like we have it in Sketch 2's graph, and I'm going to indicate where 1, 0 relocated to. That would be at negative 1, 3. And that's our final graph. So let's talk about the specs. We'll talk domain, range, equation of the vertical asymptote, and relocation of 1, 0. For the domain, what we could do is we could set the inside of the argument greater than 0. I'll do that over here. And to solve for x, we'd have to divide each side by negative 1. And that's going to flip the inequality symbol so it's x is less than 0. And what that means is that the domain would be negative infinity, 0 for this graph. And you can probably tell based on where our light blue graph is at, it's to the left of x equals 0. And all of the x values used to produce it would go from negative infinity up to 0, non-inclusive. The range will be all real numbers. As noted on the graph, the vertical asymptote equation is x equals 0, and 1, 0 relocates to negative 1, 3. So what I think I'll do is I'll save number 6 for a different video. So we'll just leave this video to one log function sketch. Of course, if you have any questions about it, feel free to let me know. Otherwise, thanks for watching, and I will see you for number 6. Thank you.